Welcome to series of database management system video lectures. Today we'll be discussing about Unit 2, Topic 8, that is denormalization of a database. Now, what is denormalization of a database? As we have already discussed about what is normalization of a data, right? So, normalization of a data is used to remove all the duplication of data or redundancy of a data is completely erased by breaking down the larger tables into smaller subtables, right? And which will also resolve the issues of functional dependencies. Now, going back, when large amount of data is being splitted into smaller subtables for the purpose of achieving duplication and then functional dependencies is called as normalization. Denormalization is for the purpose of improving the performance or fine tuning of the database. We need to bring back certain kind of attributes or the features which have to be duplicated in the existing tables instead of performing multiple number of join operations to retrieve the data. So this helps us better to reduce number of queries for merging multiple number of tables content by using joins. So this will have an impact upon the query processor and the query engine for evaluating of the data. This will take more amount of time for accessing to various data items across various tables. So to resolve with this, we need to forcibly duplicate certain set of data items in various other tables. So now to understand this better, let us look at the definition. Denormalization is a database optimization technique in which we add redundant data to one or more tables. So this denormalization refers to the process of combining tables that were separated during the normalization process to reduce the number of joins needed to retrieve the data. Thus improves the read performance at the cost of potential data redundancy and increased complexity in data maintenance. This is what the example which I have explained earlier. Now let us go through with the help of an example. Now, denormalization can be better understandable by taking two different tables. One is student table and the second is branch table. Now, student table maintains the information specific to student only. So we have four different attributes. One is student roll number, second student name, third age. Now, only these three are the attributes which are specific to the student table. Now, look at the branch table. Branch table maintains the ID of the branch. This is one. And branch name and the head of the department. So, these are specific information related to the branch table. Now, when a query is requested by the user that I need to list out all the student names belonging to various branches along with the heads of the department. So if this query has to be processed, I need to collect the information of student name and then branch name and then heads of it. So I need to maintain a connectivity between these two tables. To maintain the connectivity, we are going to store the information of a branch ID into the student table. Now, here student roll number is a key attribute. So we define this to be a primary key attribute. Whereas in branch table also, branch ID is going to be defined as a primary key. Now here in student table, in order to maintain connectivity between these two, we are repeatedly we are duplicating branch ID information even in student table for the purpose of connecting. Now this acts as a foreign key to the other table, right? So to retrieve the information more than one table, we need to write the queries using joins, right? Joins is a complex operation which is being implemented in the background, which consumes lot of query processor time and then access time. The response time ultimately reduces to a greater extent. Uh, the response time increases, so that's the reason we need to come with an alternative so that we can resolve this issue. So doing the operation reverse to the normalization is called as denormalization, but in fact it is not in the same manner. Just wherever it is required, only that set of attribute information is being duplicated in the tables. Okay. Now, what are the advantages going with denormalization? Now, retrieving of data has become faster because we are not going to perform multiple number of join operations there, right? And second one is that retrieving of data has become more simpler compared to the previous one as it involves more number of join operations. Then the drawbacks of denormalization is updates and the insertions are going to be more tough because I need to find out what can be the best attribute that have to be duplicated from one table to the other table. If the insertion is being maintained in one particular table, it should also be updated into the other connected tables. Denormalization can make update and insert as so tough. Now, data may be inconsistent because as we are going with the redundancy of data across various other tables, right? So these are the advantages and the drawbacks of denormalization. So this will be the end of denormalization. Thank you.